All right, so I wanted to take a look at announcements, make sure everybody's on the same page. So I posted a new announcement about a virtual tech expo on April 16th, which is just a couple days away. So if you're interested, if you haven't done the extra credit yet, if you attend that, let me know and you can get the extra credit for that. I understand if you're busy, that's why I'm trying to post different options for you to get the extra credit. So there's different options on the discussion board, and hopefully something works for you. I also wanted to mention Chapter 8 quiz. It was mentioned a couple times that there were a couple confusing questions that were asking the same thing. So I did add a point to everyone's score to make up for that, because two questions were similarly worded. So if you missed one, you probably missed the other as well. So I didn't want to hurt anyone's score there with that. And also, I'm going to keep trying to recruit for SWE, Societies for Women's Engineers, because I believe that if you're all in engineering, whether it be computer engineering, mechanical engineering, electrical engineering, any type of engineering, that this would greatly benefit you to be an officer, help us with this club. So if you want an application, please send me an email. I haven't received many applications yet, so I'm getting a little concerned. That's why I keep trying to get people to apply. I really think that having an officer position in SWE would be really beneficial to you on your resume, but also networking with, different people out there and different companies, and being a part of it, having the opportunity to give us ideas for what we should do for the club. So please consider running for an officer for that. And if you need more information, please let me know about that. Okay. I'm going to bring up actually I wanted to bring up the syllabus. So I gave you an extra week for Easter, and that may have affected your time to read this chapter. I hope you had a chance to read this chapter. But if you look at where we are, so I gave you an extra week for chapter 9, and I did grade those, so you should have a grade on those. And now we're moving on with chapter 10. Hopefully you had a chance to read it. We were supposed to have 2 weeks, but you may only had a week and a half, depending on how long it took you to do the other chapter. So this is a hard chapter, probably the hardest we've had so far. There's some hard content in there we're going to talk about today. Again, it's probably not going to be enough to just read the chapter one time. You're probably going to have to play with the examples in the chapter, look over the chapter, watch the video, maybe rewatch the Zoom video, maybe schedule a one-on-one appointment with me if you're having difficulty understanding it, because it's a difficult chapter. Now, with that being said, hopefully the next chapter is not as bad, but we have to get through this chapter first, and this chapter is pretty important for learning object-oriented programming, okay? Now, the next chapter is important too, but this one is really the object-oriented part of it. The next chapter is all about, what if we have these exceptions, these things that, someone doesn't type the right data into the field, what do we do? That's where we're going to learn how to control that a bit. Okay, and then we get into JavaFX. JavaFX hopefully will be kind of interesting because it's a way to, create radio buttons, checkboxes, text boxes, images, and have it be interactive. And so what we talk about today with interfaces will help you with JavaFX, because we're going to implement interfaces in JavaFX with listeners. So we'll be doing, we click on the button and this happens. So you'll have a project that you do with that where you get to be creative, and then we'll have your final exam. And that's it. We're really towards the end of the semester. So does anybody have any questions about that? I see it in the chat. If you came in late, it's okay. I'll mark you down later for attendance. Everybody okay with the schedule?
Yeah.
Okay, perfect. So what I want to do is first start off with Kahoot. So I'm going to go ahead and pull that up. Okay. We'll play this game first, see how much you know about the chapter, and then we'll go ahead and talk about it. Okay. Okay, so 3930695. Okay. If you're still signing up, that's okay. So we have a sweet president. That's good. I really hope so. Please apply. Um, so let's go ahead and get started. If you're still signing up, put the game pin in there, please. It'll be down the bottom, and you should still be able to sign up. Okay, good job. So extends is the keyword that a class inherits from another class. So we say extends it. Implements is used for interfaces. So we use extends for classes. Okay, so we have a variety of answers here. So basically, when you have a subclass and it has the same method as a superclass, automatically the subclass is going to be the one that happens. It overrides the superclass. Um, so if you wanted it to have the superclass method happen, then you can actually call it by saying super and the name of the method. Okay. So I want to actually talk to you for just a second here about this. Oh, let me bring that up. Okay. So I have this diagram just to make sure everybody understands super and subclasses. You can also call them parent and child. That makes sense to a lot of people because you think a child inherits from a parent. So if you think child and parent, you can kind of think of the inheritance process going on there. But a lot of people do call it super and sub. So you do want to get used to that terminology as well. So if you look at this diagram I have, first have an animal at the top. That would be the superclass. That's the parent. And then you have the subclass insect and spider, or child and child, right? So when you say here, you can say an insect is an animal and a spider is an animal. Another way of saying that is insect extends animal, okay? And spider extends animal, or they inherit from the animal class, okay? So what's the purpose of doing this? Like, why would you want to do this? Well, you want to put your general things that happen for animal, like your general characteristics and your general methods for animal in the animal class. So maybe you say all animals eat, okay? Now that might not be true for all animals. You know, maybe there's a different way of them taking in nutrients. So you might have to actually have a case where that doesn't happen. That's okay. If it's a consensus that most of the things that you're talking about that are going to extend the class are going to do it this way, then you put it in the class. And then if a class doesn't follow those rules, if you have an exception, that class doesn't follow the rules, then that class can override that certain section of the parent or the superclass that doesn't work that way. So you don't want to stop from putting it in there just because one particular class in the future might not follow that rule. If it's general that's true, then you put that in there, and then the ones that aren't true, we can handle that later. So, and then we can say that a fly is an insect and a bee is an insect. So we say that fly extends insect, and then we say insect extends animal. What we don't say is that fly extends insect and extends animal. Now, because Java can't have multiple inheritance. And so what that means is that you can't have a class that extends multiple classes. But you can have a class that extends a class, and then that class can extend a class. That's okay. So you can say fly extends insect, insect extends animal. Okay, that's okay. But you can't say that fly extends insect and extends spider. They can't be an insect and a spider. Okay? So different kind of spider. Yeah, there's tarantula and wolf spider. There's actually, I'm not good on my insects and spiders, so I can't take it to another level. But you can actually break this into another level. Like there's different types of flies. I'm not sure what those types are, but there's different types of flies, and could split it into another level where the different types of flies and different types of bees and different types of tarantulas. So yeah, fruit fly, dragonfly. Thank you. Yeah. And they're all different, right? What's the regular fly we see? Is it just a house fly? The the one that all kinds. Okay, yes. So yes. Okay. So different types of flies, different types of bees. You can split them even further, but what I'm getting at is when you get down to the lower level subclasses, you're getting more specific. And when you go up to the top of the chart, you're getting more general. And so you can only put the things that are true for most animals in the animal class. But then you put the things that are true for insects in the insect class. So you might say insects, for example, most of them have 6 legs. Now, I know it's not true for all of them, but most of them have 6 legs. So then if you get an insect in the future, a class of an insect that doesn't have 6 legs, it can override that. But you can put an insect has 3 body parts and a spider has 2 body parts and 8 legs. And so you can have these general characteristics of the different classes in there, and then you can extend those, and then you get access to that. So everything you put in animal, everything that extends animal is going to have that capability. Okay? And so that's the benefit is having this hierarchy, put things that are general in the top level classes, and then everything gets them, and then you're not repeating. So if you know that every animal eats, then if you don't put that in there, then every class you have to put how the animal eats. And so things that are general, you put in the top level class. I know it's kind of a silly example, but you get hopefully does everybody get what I'm trying to say here?
Yes.
Okay, perfect. So that's what we're talking about. We're talking about this inheritance. Okay, so let's go ahead to the next one. Okay, good job. So yes, every object automatically has a toString and an equals method that's inherited from the object class because every object actually extends the object class. Now, it does it automatically, so you don't have to do that. But the toString and the equals method the object class has is probably not what you want it to be. So the toString method prints the class name and the reference location, and that's probably not what you want. And the equals method is going to compare reference locations. So it's probably not what you want because unless the object is saved in the same reference location, it's going to tell you that they're not equal. Whereas you probably want to compare the properties of the objects to see if the properties are equal. So if you're going to have an equals method for your object, you probably have to write your own equals method that overrides the equals method that the object class has. And that's so that you can tell Java what properties are important to compare for your particular object. And same thing with the toString. Java doesn't know what you want to display for your object, so you're probably going to have to override the object class's toString method to put your own toString so that you can display it the way you want to, because you probably don't want the class and the reference location displayed when you use the toString method. But if you don't put those methods and somebody uses them, it'll just use the default coming from the object class. Does that make sense to everybody? Okay, I'll take
Makes sense to me.
Okay,
Yep.
perfect. Okay. All right. Okay. So when you have a subclass, the subclass is going to be the more specific class, and the superclass is going to be the more general class. So if you look here, animal is going to be the general one. That's your superclass. And fly, for example, is going to be the subclass, which is more specific. So fly tells you what type of insect, which tells you what type of animal. So it's more specific. Animal is just a general term that has general characteristics, but you can't get specific in the superclass because you haven't broken it down yet to get to the individual levels, which is the purpose of the subclasses. Does that make sense to everybody?
Yep.
Okay, good. So it should be false. Okay, so if you're using an interface, you use the word implements. If you're using a class, you use the word extends. And we'll talk about interfaces today so you understand what that is. Okay. Okay, so this is true because of the word not. It is not possible for superclasses, um, for a superclass to call a subclass's method. Um, you, let me try and explain this. You can go the other way around. A subclass can call a superclass method, but a superclass can't call a subclass method because, you're looking at this chart again, a fly can call a method from an insect or an animal, but an animal can't call a method from a fly because not all animals are flies. So it doesn't make sense for a superclass to call methods and subclasses because the subclasses are the more specific one, and the superclasses, it has multiple things coming off of there. So it doesn't make sense for superclasses like insect to call a method in fly or bee because the insect can be multiple things. It's not just going to be a fly or not just going to be a bee. But it makes sense for a fly to be able to call methods in an insect, or insect to be able to call methods in an animal, but not the other way around. Yes, so you just, does that make sense to everybody? Do you have questions or still have questions about that?
Makes sense to me.
Okay, so I know that was a little tricky, maybe the wording of it, but, and it seems like, okay, you should be able to call things from a superclass, right? Like from a subclass, a superclass to a subclass. But then when you think about it, the superclass is your more general one, and so you shouldn't be able to take it to the next level, because that level is supposed to encompass a bunch of different levels. So it doesn't make sense for it to access specific ones when it can be any different, when it can have a bunch of different subclasses underneath of it. I don't know if I worded that confusingly, sorry. But that's why I would refer back to the diagram. Animals shouldn't be accessing methods from insect, but insect can access methods from animal. Okay, because not all animals are insects, right? So, but all insects are animals, if I say it that way. Last question.
Protect.
Okay, got it. So I want to refer you to page 647 if you want to know more about this, but basically there's 4 modifiers that we would use. We've been using 2 of them, public and private, all along. Public and private are complete opposites. So private means that you can't access it from any other classes. Public means the opposite, you can access it from all other classes. It doesn't matter if they're in the same package or not. And then you have something known as protected, and you have a default, which is when you don't put a modifier at all. So default and protected are your 2 middle ones between public and private. Now the difference between protected and default is that they can both access classes from the same package, whether they're, let's see. So protected, you can't access classes from outside the package, but public or default, well, actually both of them you can't access classes from outside the package, but default you can't access from the subclass outside the package, but protected you can. So if you have subclasses outside the package, protected can access them, but default can't. And that's the only difference between those two. They're the same otherwise. So the 2 main ones are public and private, but sometimes you'll want protected, and sometimes you can even use default, just depending on what you're doing. So if what you're doing is influenced by the package, then you want to take a look at default and protected to see which one of those is a better option for what you're doing. But if you want everything to be accessible all the time, then public is the way. And if you don't want it to be accessed outside the class, then private. Otherwise, something in between, you want protected or default. All right? See how we did? All right, good job. I'm going to go ahead and close Kahoot. And then I want to go ahead and pull up NetBeans for you. And I'm actually going to show you a UML diagram that I want to take a look at with you. And I have some things in the chat. Let me make sure. Okay. So I have this ship class, and then I have these 2 other classes called cruise ship and cargo ship. Okay. And basically, we want to have the ship be the superclass, and we want to put all things that are common to ships in there. And then we put things that are common for cruise ships and the cruise ship, and things that are common for cargo ships and the cargo ship class. Now you can see that this little arrow indicates that cruise ship and cargo ship are going to extend ship. So they're going to inherit from ship. So anything the ship has, these 2 will also have. Okay, so that's what the arrow tells you. So if you look at the ship, we'll say that all ships have a name. So we're going to put the name attribute in the ship, so we don't have to keep putting it in all the individual classes underneath that. So put it in name in the ship, and then they all have a name. And then we'll put a year built, when was the ship built, and then we'll have a constructor that sets those values, we'll have setters and getters, and we'll have a toString that prints them off. All right, and then the cruise ship, we're going to add another attribute that's specific for cruise ships, so passengers. So we'll say that cruise ships have a number of passengers, and then we'll have a constructor, and this constructor is going to have another parameter that's going to have the passenger variable, and then we'll have a setter and getter for the passengers and a toString that's going to print that off. Okay. Now, the cargo ship will say that there's a specific attribute called tonnage, and the tonnage is going to say how much the ship weighs. And so we'll have a constructor, a setter and getter for tonnage, and a toString. Is everybody okay so far with this UML diagram?
Mm-hmm.
Okay, perfect. I think that kind of helps you lay it all out, what's going on before we actually look at the code. So let's take a look at the code. Let's take a look at the ship first because that one's the easiest, and that's the super class, so it makes sense to look at that one first. So the ship has all the details that are more general for all ships. Okay, all ships have these things. So a name and a year built, and they're private, so they belong with the ship. Okay, now I have a constructor that sets these two variables, a set name, a set year, a get name, get year, and a toString that prints that information off. So all of this is just review from what we've already talked about in this class. Is everybody okay with that? Setters and getters, constructor, all of that should be
Right.
review. And then if we look at the cruise ship, this is where we start talking about this chapter. So the cruise ship is also going to have a name and a year built because we're going to say the cruise ship is a ship. So how do we say that? We say cruise ship extends ship, okay? And then that means that it has all the attributes that a ship has, okay? Now, we want to add another attribute that's specific for cruise ships. We want to add the number of passengers, okay? So we're going to put the number of passengers on there. And then this is where we get a little more complicated. So the two variables that we had, name and year built, they're actually private for the ship, okay? So when we pass in the information when we're creating the cruise ship, the N stands for the name and the Y stands for the year built, and the P for passengers. So this looks exactly the way we did it before. Passengers equals P. So take whatever comes in as P and set it for passengers. That should make sense because that's what we've been doing all along. So this is something new that you're seeing. So how do we set the name and the year built? Well, we can't say, you know, name equals N because name is actually a part of the ship file. It's a private variable over here. So you can't say this line over in the other file because this is actually belong to here. So how do you get those values so that you set those values for the cruise ship? Well, what you're going to do is you're actually going to, let me go back to the cruise ship. You're going to say super, and you're going to pass in those values. So what does this do? This calls the super class of this cruise ship class. So how does it know what the super class is? Well, it extends it. So it's going to, when you say super here, it's going to go to the constructor for the ship because that's what that does. It goes to the constructor for the ship because that's what we're extending here. And it's going to pass in the N and the Y values that were passed in when you actually created the cruise ship object. Is everybody following so far?
Mm-hmm.
Okay, so if I go over here, you'll see that this constructor for the ship takes in the N and the Y, and it's going to set those variables here. So when I say super N and Y here, that's going to call the constructor for the ship, take in N and Y and set those variables here. Okay, now one thing I want to caution you about. When you're doing your Java code, see how this ship class does not have a constructor that doesn't have any parameters? It doesn't have a no R constructor, they call it. It just has the one with the name and the year as the parameters. If you were to not do this line here, you would have an error in your code, okay? The reason is because Java doesn't have a default constructor. If you add a constructor, it doesn't do its default constructor. Remember how before we talked about you don't have to put a constructor on there if you don't want to. Okay, you can leave it. If you leave it, then it automatically creates a default constructor. So when an object is created, it calls a constructor, and if it doesn't have a constructor, it calls the default constructor, and if you don't put one, then that default just doesn't do anything, right? But once you go ahead and put a constructor, it doesn't create that default constructor that doesn't have any arguments anymore. So if you go ahead and put parameters in here, you're telling Java, you're telling it, you're going to call this constructor setting those values, because otherwise, if you have these parameters in the constructor, Java's not automatically going to call that constructor because it doesn't know what to set for those values. So this isn't automatically going to get called, and that makes Java have an error, because it says, if you were to take out this line of code, how would I know what to put in here for this constructor? So that's why you would have an error if you were to take out this line. But as long as you do this, then you're good. If you take this out, you have an error. So what a lot of people do is they create another constructor that doesn't have any parameters, that's empty, just to keep it from erroring, in case in the future they do want to create a ship that doesn't have a year and a name. Maybe you just want to set them as default. So you can have another constructor that doesn't have the two parameters for name and year, and then you just make the name and the year something basic, like just put an empty string in there, put null or put an empty string, and then year built, you can just put 0 or something for just having default, or a default year. So it's up to you. But all I'm trying to say is that if you decide to go this route and have a constructor that has parameters, you do need to make sure that you call that constructor by saying here in the subclass super and passing in the values, because Java doesn't automatically create a default constructor for you once you go ahead and create a constructor that has parameters. So you could get an error if you don't do that. Does that make sense to everybody?
Yeah.
I'm not sure that I explained that very well, but hopefully that makes sense. Okay, so I know this is new, so I'm just trying to go through step by step. This one just has the setters and getters for the passenger and a toString. Now you are able to use getName, even though getName isn't a part of this file, and that's because getName is a public method that belongs to the ship, and since cruise ship extends ship, then you have access to getName, and you set the name, so you should be able to get the name back. Okay. All right, so let's take a look at cargo ship. Cargo ship has another attribute, another instance variable called tonnage. And when you're doing it, same thing. This part is going to be part that gets set by doing the constructor of the ship, because the year and the name belong to the ship. And so what you need to do is take in these values when you create the ship, but only the tonnage part is getting set here through this constructor. The other parts need to get set through doing super and passing those values into the ship class, okay? This line, by the way, has to be first. It can't be after this line. So you get an error if you switch these around. It wants the super line to be the first thing in your constructor, okay? And the rest of it is just your setters and getters and your toString, okay? Are y'all ready for the really cool part? Where we create the objects?
All right.
Yeah.
Yay. Okay, so in the main method, you go ahead and create your objects. But instead of just creating an object of cargo ship and an object of cruise ship, something different here. So we're creating an array of ships. So something that's really cool that you'll learn about in this chapter, if you haven't learned about it already, is something called polymorphism, okay? So polymorphism means that you can have, like for example, this is polymorphism, you can have a data type that is a superclass type of data type, and you can have objects that are actually the subclass types. So like I can have, if I have an array of ships, for example, the first ship is just a ship object type, okay? So it just includes two values, the name and the year, okay? But the second ship, the one in index location 1, is going to be a cruise ship. So you can have a data type that's ship, superclass level, and by doing that, you're allowing yourself to have different types of ships in your array. If you were to create a cruise ship array, you can only have cruise ships in there. But if you create a ship array, then you can have all the different subclasses that are under that superclass as your object types. So that's polymorphism is being able to have a data type of a superclass and being able to have the subclasses of your object type so you can use them. Does that make sense?
Yes.
So Professor,
Yes.
it's going to pass the value to the ship, cruise ship, and the cargo ship.
Yeah, so you'll have see how this one is specific. This is like the number of passengers. That will get set for all of this information will go with this cruise ship. So if you were to access ships index 1, it will be all the cruise ship values that you have here. And then then this is the tonnage for the cargo ship because that's specifically for the cargo ship. Okay. It just allows you to not have separate arrays for each type of ship, but to have a more general one that ships so that you can then have objects that are more specific. And I want to show you another example. So this one will print off the ship information. So if you say, remember, if you do this, it's going to do the toString. So it's going to print the information about all of the ships that you have. So see here you have the information about the different types of ships. Okay, what did I want? I wanted to show you interface. When you're reading about interfaces, did it make sense? You're okay with that? Somewhat, okay. All right, so let's take an example. This one's given in your book. Now I want to show you, I am going to add the ship demo to your course because I don't have it on there right now. But I want to show you, just in case you're not aware of this, I hope that you've been using this, but if you're not aware, now's a good time for me to show you. Under each module, there's this thing called course resources, okay? And that's where you can find like the lecture video. So I know that when I do these Zoom sessions, I'm not teaching you every concept from the chapter like I would normally do step by step. I'm kind of just summarizing and then we're doing a breakout session because we don't have as much time to do that. So that's what you get in here. The lecture goes through every concept in the chapter, okay? So if you're not watching those, please watch those. And then the course notes, I have all the things I used in my lecture video and some of the things I use in my Zoom session and here as projects that you can experiment with. I don't collect them or anything, but so this project we're about to do is actually in that course notes folder. So if you don't have that downloaded, please download that because you'll get access to all of these projects. Now, the only one I don't have in there is the ship demo, and I'm going to add that to Canvas for you, so you do have that, okay? And then, I know some students were still asking me how to make an appointment. Remember that I have this booking link, so if you need to talk with me individually, you need some extra help, please don't hesitate to email me or make an appointment to meet with me, okay? So I hope that you're using this course notes zip folder because that gives you the projects, especially for this week because this content's very difficult. And I think the way that I really believe that the way you learn is by experimenting with it. I don't think that just reading about code is really going to help you code. Listening to me talk about how to write code probably isn't going to help you code, but actually writing code is what's going to help you code. So like you trying things out. What happens if I put this here? What happens if I change this? What if I do this? That's what's really going to click and stay with you. Until you actually do it, I don't think it helps as much. Yes, reading about it is great. Listening to me talk about it is great. That's why I like the breakout sessions because you actually get a chance to do it together, to try and do it together. So you have these projects, so please play around with them and see if you can make them work. Okay, so this is an interface. This is where it gets really exciting, guys. So we have something called an abstract class. And I'm not doing an example of an abstract class, but I did do abstract class examples in the lecture video, and you have them in your book. But okay, so let's talk about what an abstract class is. An abstract class, let me pull up my diagram again, is great when you're doing classes that extend other classes because an abstract class is a class that's never going to be instantiated. What do I mean by that? Well, you might make animal an abstract class in this example because you probably don't want to create an object that's an animal, okay? Because you want to be more specific about it. I would create a fly or a bee or a tarantula or a wolf spider, but I don't want to create an object that's an animal because an animal doesn't give me a whole lot of capabilities, okay? I get all of the things that are specific, down here at the lower level. So I want to create objects of these down at the bottom, not of these top level things. So you can make classes that you don't want to be instantiated abstract, and then they can't be instantiated. They can be extended, but they can't be instantiated. Okay, does that make sense, everybody?
Yep.
Okay, now one cool thing about this is you can have abstract methods in your abstract classes, and those methods can be methods that you force the methods that those methods can be forced for any class that extends that abstract class. So then you have to go ahead and override those methods if they're an abstract method. Okay, so what does that do? That ensures that if you want something to be in the lower level classes, if you put an abstract method in the abstract class, that they have to put that method in there that is specific for that class. Okay. Now, if you're saying all this and you're saying, well, that's pretty cool, why would I need interfaces then? Because an interface is a way to have methods that are forced to be implemented in your class. So if you implement an interface, you have to use the methods that are in the interface. Okay. So it's kind of like a contract. Like, I am writing this interface, and if you implement my interface, you have to use all of these. Okay. If you don't use one of them, you're going to have a problem. Okay. So if you can do that with abstract classes and abstract methods, why have an interface? Well, one of the problems that you have, we talked about this before, is that classes can only extend one other class. They can't extend multiple classes. But guess what? Classes can implement multiple listeners, or not listeners, I'm sorry. I'm thinking about JavaFX. I have JavaFX on the mind, I guess. Because I wanted to talk to you about an example with JavaFX. So classes can implement multiple interfaces, but cannot extend multiple classes. Okay, so that means you can have multiple interfaces that you can implement, and so you can get what you need to get across that way, but you can't have multiple classes. So we are going to talk about, in the JavaFX chapter, when we get there, we're going to talk about something called listener. And a listener is a great way, like if you're creating a form and you want something to happen when someone clicks on a button, you have something called a listener. And so these listeners are interfaces that tell you what you have to have in your code to make it work. And so we're going to use that in the JavaFX chapter with having, when the user clicks in certain places, certain things happen. So when they click on a radio button, what happens? When they click on checkboxes, what happens? When they type something into a field and click on a button, what happens? So we're going to talk about that. So we'll do lots of interfaces in that chapter. So we have to know what an interface is and how it works. And that's what we're going to talk about today. Yes, like events from JavaScript. Okay, so interfaces. So let's get back to our interface here. So the difference when you're writing an interface versus a class is you put the word interface here. And then you can see something unusual. When you write your method in your interface, your method doesn't have a body. Okay. Now there are ways to get around this. You can write a default method in here that does have a body. But typically when you write an interface, you have methods that don't have bodies. And the reason is because you're telling people that are going to implement your interface, you want them to have a get retail price, but you're not telling them how they're going to go about having that method. Like, what is that method supposed to do? That's up to them, but they must have that method. And that method must return a double, and it must not have any parameters. Okay, so this is telling it how the method works, but it doesn't, it tells it like what needs to be included, but it doesn't tell it how it specifically works. Okay, so it doesn't have a body. So when you do like compact disk, this example implements the retail item, then you must have that get retail price. Now, you can have other methods as well. It doesn't say that you can't have other things in your class. It just says you must have this specific method because you implemented the interface that has that method that says you have to have it. If you take this out, then you get a problem with your code, and it tells you this class, see how it tells you is not abstract and does not override abstract method get retail price and retail item. So it's basically saying, hey, you didn't put that get retail price in there, that method, and you're required to do so because you told me that you're implementing this interface, and this interface has that method. So you must put that method in your class because your class implements my interface. If you're going to implement my interface, you must follow the rules and put all the things in there that I listed. Otherwise, I will not compile. Okay? So
These kind of remind me of function prototypes from C++.
yes, in C++, you are required to put for your methods the prototypes, and then that forces you to have those, right? And in Java, you're not required to do that. But yes, you can kind of think of it. It's like a forced way to have methods in there to ensure that everybody has those methods. They can't get around that, right? They can't leave them off, and they have to have them. So I can kind of think of it like that. Okay, so no, I didn't want to go here. Sorry. I want to go to the DVD. The DVD also implements the retail item. So that means it must have this method, right? Okay, now it has a bunch of other methods with setters and getters for all the other attributes that it has. Okay, and then I'll go back over here. So when you create these objects, I have a compact disc called CD, and I have a DVD movie called movie. That's created. Those are the two objects. So CD and movie. And then I wanted to show you something that you can do. Here goes our polymorphism, right? So you can use polymorphism with an interface. And what's cool about that is if you're writing a method and you want to show the prices, you have two different classes. You have a compact disc and you have a DVD movie. But you don't want to have to write the show price and have one that takes in a DVD movie and one that takes in a compact disc, right? So you can combine them because they're both using the retail item interface. They're both retail items. So if you pass in a retail item, you can pass in either a compact disc object or a DVD movie and use the get retail price for them. So cool, right? Or so confusing.
Still a little tricky, but I think I'm catching on.
Okay. So it's just, I know polymorphism is a really difficult term to get, but it's pretty useful because if you think about, you have these superclasses and you have these subclasses, and you want to be able to write a method, and you maybe want to be able to pass in all objects of that superclass. Like I have here, maybe I want to be able to pass in all animals, or maybe I want to be more specific and pass in all insects to my method. I don't want to have to write a method that specifically passes in flies or specifically passes in bees. If I want to pass in all insects, then I can do that with polymorphism. And then if I have a fly object or a bee object, they can be passed in because they're both insects. Or if I write it even more general and write an animal data type for my method, then I can pass in any animal data, any animal object from my list. Okay, it leaves it more open. So you can take it to any level you want as the data type. But if I take it to the insect level as the data type, then it has to be an insect, of course. And if I take it to the animal level, then I can have any of the insects or any of the spiders. So it just depends on what you're talking about. Or if you only want flies, you could take it to the fly level, right? When you create the object, most of the time, you do want the object type when you're creating the object to be the fly or the bee. But when you do the data type for the object, you can put a more general one. Or if you're writing a method, you can allow your data type that's taking in the object to be a more general data type. Okay, and that can include interfaces as well. Are y'all okay so far? I need you to kind of understand interfaces before we talk about the next thing.
Professor,
Yes.
so if we use The retail atom and the atom. So which subclass are we going to use? Is the retail atom or the other one?
Whenever you do it, you get to pick. So whenever you say show price for it,
Mm-hmm.
I don't actually have it here, right? Do I get title? Oh yeah, show price. You get to pick. Whoops, I don't know what I did there. Ah, okay. So show price here. I highlighted it. My computer is not cooperating today. So when you call the show price method, you pick what object you're passing in, and that can get passed in. So as long as whatever object you're trying to put in here is implementing the retail item interface, then you're okay. So CD is this compact disc up here. And because compact disc, I keep highlighting, it keeps unhighlighting. Because compact disc class implements the interface here, I am trying to move around and it is not doing what I want it to do. Okay, so you can see it implements the retail item. So as long as you use an object that's compact disc, then you're okay because it implements retail item. But you can also use a DVD because DVD also implements retail item. So when you're over here, let me go back here. So when you create your objects, as long as they're compact disc or DVD, which are the only two options we have, they both implement the retail item. So here, when you say retail item is the data type, then when you call the method, you just say what object you want inside here, and it passes that object to this item variable you have here. And it's okay with it as long as the object that you're passing is implementing the retail item interface. And they are, because the CD and the movie are, those classes are implementing the interface. So you're good. So it passes the CD to the item. And then when you say item get retail price, it gets the item for that particular object. Okay.
But line 32, we also pass the movie to the.
What's that?
So on line 32.
Yes. Yes. And then this one does this one. So it does it separately. It does a print for the CD and then it does a print for the show price if you run it. So it calls that method twice, once with the CD and once with so it prints so you can see it does it for the CD and then it does it for the movie. So you see the CD, get retail price here. You have it, and then you have the movie.
It's similar to the things we did before, right? We're passing something on the.
Yeah, except the only difference is it's using polymorphism here. Instead of putting specifically, I could have put compact disc there, but that would only allow objects that are type compact disc. Or I could have put DVD movie there, but that would only allow objects that are DVD movie objects. But if I put retail item, which is the interface they both implement, then it allows any of the classes that implement that interface to be passed in as objects. So it opens it up to more objects. It can be compact disc or DVD movie. And I'll have to write two separate methods, one for passing in compact disc and one for passing in the DVD movie. Does that make sense?
Makes sense.
Yes. So this doesn't limit anything because you have objects that are actually like the CD is a compact disc object, right? And the DVD is a DVD. It's not. So you have to be careful though. Okay. So when you're using polymorphism, the way it's done here doesn't limit you. Okay. But you have to be careful because let me pull up that one that I was doing before. I want to show you the ship one again. One of the drawbacks to doing polymorphism, there are some. I can do this, for example, line here. I want to get the name for ship one by saying the index location and get name, because get name belongs to the ship class. But if I try to use the cruise ship method, one drawback. It doesn't know what that is because this data type was set as ship. So it only has the methods that belong to the ship. Okay. So it kind of limits you a bit when you do that. But doing this one that I just did here through a method is fine. But because the objects are actual objects of that data type. Now, if you were to go and have like an upper level class, which I don't have here, I could put the interface retail item there. But if I were to put retail item as the data type, then I would limit what I can do with it. I would limit the methods that I can use. So I have to be careful of when you're putting superclasses as the data type, because it might limit you with the methods that you can use. Okay. If we understand interfaces, I want to take it to the next level here, so bear with me because this is the part where most of you are saying, this is where I completely lost it, right? Is when we got to the anonymous interclasses. Okay, so here's an interface, which is very basic. It has a calculate method, okay? And you don't have to write public up there for the interface because it is public by default, but you can if you want to. But this calculate method is going to take in a number, that's the parameter, and it's going to send back an integer number, okay? Take in an integer number, send back an integer number. It doesn't say what the calculation will be. It just says that these are the specifications for how you do this method. You must have a method in there that takes in a number, that's calculate, and sends back a number, okay? And however you do that, if you want to multiply, divide, or what equation you want to do is up to you, but you must have this calculate method if you're going to implement this interface. Does that make sense to everybody? So far, so good?
Yeah.
You implement this interface, you must have that calculate method. Okay, now, there's a shortcut for that. So we talked about this with the interface we just did with the CD and the DVD. So in the CD and the DVD example, we just put that get retail price in the class, the DVD one and the CD one, and then we were able to use it. We were able to create objects of CD and DVD, and we were good. But there's a shortcut for this. So sometimes programmers like to shortcut things. Sometimes a programmer might not want to create a class that implements the interface just so that they can put the definition for the body of the method that's required. If they're not going to have a bunch of other methods and they're just going to implement that one method that's required, you can do it in a shortcut way called anonymous interclass. It makes it a little easier than having to create a new file. And I don't know if it makes it easier to understand, but it makes it easier than having to go and do the typing for creating a new class. So, but it's a little harder to understand until you get used to it. So bear with me. I'm going to explain it and then I'm going to do it the longhand way because I think that'll maybe help. So what we have here is this interface called int calculator. Okay, so we have that here. And then we have an object named square here. And you're probably saying, you can create an object of an interface? So this is how we do it. So this right here, these curly braces, says that typically we would create a class that implements the interface that has the calculate method in it. And we would then create an object of that class. But we can shortcut it by creating an object of the interface and putting the method that we're required to have inside of these curly braces here. And we don't have to create the class, so we don't even give it a name or anything, because there's no purpose to it, because all we're doing is trying to create this object that actually uses this calculate method. Okay, so you can do that by this shortcut way. And then when you want to use the calculate method, just as before, you would put the name of the object and you would put calculate, and it would work the same way you did before. The new thing is you're not creating a class that implements the interface that has the calculate method in it and then creating an object of that class. So if you're saying, whoa, bear with me for a second. I want to comment this out and then we'll come back to it. How would we do it the longhand way? I would go up here to File New. Okay. And I could call this class whatever I want to call it. I could call it C. Okay. And I'm just going to eliminate this to make it easier. Okay. I'm going to go over here and I'm going to grab this calculate method that I have here. Okay. So I'm going to say, okay, I want to have this class and I want it to implement the int calculator. Can I spell it? Calculator. Okay. It's going to implement the int calculator. It has a problem with it right now because I don't have the method that I'm required to have in there. So it's telling me that I don't have the calculate method in there. That's okay. That's the next thing I was going to do is put my calculate method in there. And so Java's telling me, hey, you have to fix this. And let me fix my formatting a bit. So I put this calculate method in there now. It should be good. In this interface, it requires me to have a calculate method. My calculate method has to have a parameter of some number that's an integer, and it has to return an integer. So over here, I have my parameter. I return an integer. I have my equation that returns, I multiply number times number. Okay, so I satisfied my case right now. Okay, is that good?
Yep.
Go back. Everybody okay so far?
Yeah.
Okay, then I go back over here. Ignore this up here for a second. And this is the way I would have done it the old school way. I would have said, I'm going to create a C object, because that's the name of my class here, right? And I'm going to call it square, oops, equals new C, right? And that's going to create my object, my square object, right? Now, when I want to use the calculate method, I'm going to have to pass in a number. So here's where it asks for an integer and it takes in a number, and that's where it's getting that number variable from. So whenever you run it, it's going to ask for a number. Okay, so down here I'll type a number, maybe I'll type 5. And you know that it multiplies 5 times 5 because the equation was to take number times number and return it. So it gives me back 25. So all I've done was say, okay, I have this interface. When you use my interface, you have to have this calculate method. Take in a number, pass back a number, okay? So when I implement that interface, I wrote a calculation method, takes in a number, passes back a number, here's my equation, okay? So over here, when I create an object that's type of the class that I created that implements that interface, then I can use that method in there, right? By saying the name of the object, the name of the method. But I have to pass in a number. And so I just chose to take it in this way from the scanner, but you could just put a number in here, right? So the calculate method takes in a number. When I put a number in there, it's going to do the calculation of multiplying it times itself, which is what's in here. Tells it what to do here. And then it sends back the answer, and that's how I get the answer here. Okay? So the purpose of the interface is just to tell you what you must include in your class that implements it. It's a way of forcing people to have the same methods, okay? So if you're going to implement my interface, you must have these methods. You must have a calculate method that takes in a number and sends back a number. Doesn't matter what calculation you put in there, as long as you follow those rules, right? Doesn't mean that you can change your calculate method to be void and that you can print it off here, right? That's not going to work. That wasn't part of the rules, right? So you still must follow the rules. So I can't just do whatever I want. I can't make a void method here because it specifically says that it must return an integer. So mine must return an integer. Just because I have a calculate method, it has to follow all the rules. Okay? So I have to put this back. I can print if I want to, but I must also return. I can add whatever else code I want, but the rules that I must follow is that I must have this method, it must return an integer, and it must take in a number. Whatever else I want to put in here is fine, right? That's up to me. But I must have that in order to implement this. If I don't implement this, it doesn't matter. But I implement this, I have to have that. So then here, I can go back, and that's how I use that calculate method. I have to create an object that comes from this class that implements that interface, and then I can use that, right? Are y'all with me?
So in a really simple case like this, where we're mostly just explaining how the interfaces work, if we wanted to simplify our code, we could actually just ignore the interface entirely, and the only thing it's doing is forcing our C.Java to have certain stuff in it. So we could actually just leave off the interface and just manually do that, right?
Right.
It's just essentially a reminder system.
Right. Well, yes, a good point. So if you were to leave this off, you could still do the same thing. It would still work. And because you've been doing this all along, you've been having methods, you've been creating objects and using those methods. So this should make sense if you're ignoring this anonymous inner class. If you weren't to have an interface, you're right. The only job that the interface is doing is forcing me to have this. But then when I go make changes to this, like I was doing before, if I were to change this, then nothing is stopping me from doing that. So having an interface is a good way to keep consistency among classes. You don't want people just doing whatever they want, right? So you're forcing them to have certain parameters and have certain returns and to have certain names for their methods and to make sure they have those methods. So they could just, if I don't implement that interface, I could just leave that method off altogether. So as part of a system, interfaces are great for ensuring stability because people just do whatever they want and they don't follow the rules.
Scott in the chat said, so interfaces are like data validation for programmers, having it is similar to having an @override notation.
I see that now. Yes, thank you for letting me know. Yes, the override annotation. Yes, that's great because it forces people to not be able to change the name of it, to not make adjustments to it because it overrides. So you can't change like the parameters, you can't change like the return type, you can't change. Yes, and it also forces you to have it. So it forces people to have those methods. So and besides forcing them to have it, they have to be consistent with having the rules that are over here. So yes, you could write down rules for your company and say, every time you add a class that, you make sure you have this method in there, but, not everybody is going to follow those rules and going to do it the way that they're supposed to do. So yes, it is validation to make sure that everything's consistent and everything's following the rules without having to write rules for people and then hoping that they follow the rules that they're supposed to follow. If that makes sense. Does that?
We have, but in this code we have the interface, so we cancel the implement. It will be something wrong, right?
No, you could take it off there. I mean, just as they were mentioning, you don't need to be able to write this calculate method. You don't have to have an interface to do that because what does the interface do? Well, the purpose of the interface is to ensure that there's consistency among your classes. So if you're supposed to implement an interface, then you have to follow the rules of the interface. Like you have to follow that this returns an integer. If you don't implement the interface, then you can do whatever you want. There's no rules, right? So implementing it requires that you follow that there's a return here and that not be void. But taking off that implementation, there's no rules. So you can do whatever you want with it. You can do whatever kind of calculation method you want. You can call it calculate this. You can put whatever return type you want. You don't have to put one parameter. You can have 0 or 2 or there's no rules if you're not implementing this interface. There's no rules for this.
So
there's Java syntax rules, but there's no rules for what you return and what you do.
So
okay.
what do you mean? Okay. So
Sorry, go ahead.
Even we have the interface, we do not have to implement. If we do not use the implements, we can do whatever we want. But if we use the implements, we have to follow the interface set.
Yes, exactly.
Okay. So even we already create the interface, we do not need to use the implements.
You do not need to use it, but I mean, there's a lot of benefit for using interfaces for making sure that people are consistent with how they do things. So yes, no, you don't have to, but it creates consistency. So it's recommended that you have interfaces for any methods that you want to be consistently used throughout your classes. So if you wanted to force, like in your book, it talks about having different types of students. It has like a generic class, a super class called a student, and then it has different types of students, like a computer science student, engineering student, math student, right? And then if you wanted to force that those classes have certain methods, then you have an interface that forces that they have that. If you wanted them all to stay consistent and have to have certain methods, then you would do that. Otherwise, they can do whatever they want and they cannot put those in there.
Okay.
Okay. All right. So in your book, it has an interface for that, and it has it so that it forces it to do that. Okay. Let me go back here. So this was the longhand way, creating this class and putting this code in there, and then creating an object of that class was the longhand way that we just talked about. But I don't need this class, right? I can do this anonymous inner class that we were talking about before, right? I can leave this file in there, or I could take it out. I'm not using it right now if I don't do this. What this is doing is a shortcut way to do what I just did by creating this file and creating an object of that file. By saying that I have an object of the interface type, putting these curly braces here, and then putting that calculation method inside here, I don't need to create a class and create an object of the class. I can shorten it by doing this instead of going through what I just did with you all. Does that make a little more sense?
Wait, isn't there another shorten it? Like, is it called like lambda?
Yes, we're gonna get to that in just a second, but I didn't want to do that before this made sense,
Okay.
because that's even more complicated, I think. So this
Scott did say in the chat, so anonymous classes are just shortcuts to use an interface without having to use the definition with implements.
Yes, it's just a shortcut. If you have a simple interface that just has one method and you don't want to have to create a class that implements that interface and then create an object of that class, if you use anonymous inner classes, it saves you from having to create the class that implements the interface. You can just create an object of the interface and then put your body for your method in here. It's a shortcut for it. What it does is saves you from having to create the class, the extra class that I just created over here, which is not a huge deal, but you know, some people don't want to have to do that. So this is a shortcut. This completely works and is the exact same thing, but you should know what people are doing if they ever do that. Okay, and then
can I ask a question real quick?
Sure.
Then it wouldn't work if we had to deal with like two method.
It would say that again. It wouldn't work
if we had to deal with like two method. I mean, if there was like another thing we had to calculate.
Oh, if you had like more than the calculate method.
Yeah.
No, if you were just, you could put the other methods in here too, like if you wanted, but it's just simple. If you're not having to create a class that has other methods besides the methods that are in the interface, like for example, the DVD one that I did, the DVD and the CD one, let me open it real quick to show you. Let's look at the compact disc. The compact disc implements the retail item, and the retail item only has one method that's required. So in here, it does have that method that's required, but it also has all these other methods, right? So it makes sense to create this compact disc class because it has all these other attributes and it has all these other methods that belong to it, right? But in this particular example, I don't have any other methods and attributes and things I want to add to this class. So they're saying an easier way to shortcut that is to do this anonymous inner class. There's no point in creating the class to just put the methods that are in the interface in there, okay? If you're not going to have any other methods or attributes, if you're going to have other methods or attributes, then you're going to want to go ahead and do it this way, okay? But if this is just a shortcut for simple classes that are just basically implementing the interface and they don't have any other methods that they're doing or anything like that. If you're going to have other methods, then you're going to want to create the class, okay?
Yeah.
But you can have other methods in your interface that are in here, but just other methods in your class that you want to add, then you're going to want to actually have a class that has the methods in there.
That was what I was asking.
Okay, yeah, but you can have other methods in the interface. But if you have other methods in the class that you want to have, like this one has a bunch of other methods and attributes, then you just go ahead and create the class just like you've been doing. This is just a shortcut for something simple. Like if you only have one method in there, you just want to basically, you don't want to have to create the class and then create an object of the class. This shortcuts it. And then Lambda shortcuts it one step further. So it takes this process and it makes it even shorter. So if I go to the Lambda here, it's actually the same interface. Actually, it's not. It has an extra parameter. I'm sorry.
No.
It could be the same, but it has an extra parameter. It does return an integer. So in the Lambda one, you're doing the same thing, except you don't have to do that anonymous inner class. You actually start off the same way, except this is the Lambda notation. So you don't have to put the name of the method. This works if you have one method, right? In your interface, you don't have to put the name of the method. You just put the parameters, and then you put the body of it goes here. So like this is going to, if you look here, this calculate method, you don't have to put calculate because there's only one method in there. It's going to have two parameters, right? So they call it x and y, right? And then it's going to multiply x times y. And the method is already defined as it's going to send back the integer for you. So it's going to send back the integer for you whenever you use that calculate method. So down here, when you use the calculate method, it's going to send back the answer for you because that's what it's detailed to do here. So if you use lambda, this just tells it this is the body, these are the parameters. So this is a even more slimmed down version of what we just did with anonymous inner classes. Is you can just put the parameters in the body. And then here, I still have entering two numbers, and then it knows to do x times y with those two numbers. Because basically, it's going to take number, which comes from here, and number 2, which comes from here, pass those into x and y, and then x is going to get multiplied times y, and it's going to return the value here. So if I were to run this, it's going to ask me to enter an integer number, so I can enter 3, 4, and it's going to tell me whatever those two multiplied together is as the result, because that's what you're saying to do here is the body of the calculate method. So that's how you simplify the calculate method implementation with a lambda. Now, of course, if you don't want to do x times y, you could do whatever you want here. I could add them together, and then I would get, if I do 3 and 4, I would get 7 instead of 12, right? I could do whatever I want here as the symbol for the equation. This is just the equation that I want to do, so that equation can be whatever you want it to be. So in your book on page 687, there's a whole description about lambdas and how to work with different number of parameters, no parameters, multiple parameters, and equations. And so there's examples there. I think the best way, again, to learn this is to do it. So what I would do is I would use the Lambda project that you have here as an example to work from, and then try and create your own project with your own Lambda expressions, see if you can do it. So like instead of, maybe instead of a calculate method, maybe try doing something else, some other type of calculation, or maybe do a different equation for your calculation. Maybe do, like this one has 2 parameters, maybe do a calculation with just one, like we did before. Maybe take off the second one and see if you can fix the lambda for it. So see if you can modify this program, or see if you want to create your own based on this program to see if you understand how it works. Or like you could take this anonymous class one, if you want to practice anonymous classes, try to do what I did. Try to write out the longhand version, try to write your own class for it. Because the one I gave you doesn't have this new class that I have with this new implementation. So try and see if you can do that, what I did. Then see if you could do the reverse. See if you could take out the anonymous in our class and put it back in, with using an example. Maybe have the, I think there's another example in the notes that I have for you, but maybe see if you could change the names of things and just try to play around with it. See if you can understand what's going on with it. Does that make sense to everybody? I think that's the best way to understand it. I know I'm not collecting it, so I won't know if you do it or not, but if you're having a hard time with it, just reading about it, just listening about it, you actually have to do it. I think you have to say, how would I do this? And then try and do it. And then when it doesn't work, please come to me. Send me an email with it. Say, I have an error. I really don't know what's going on, or set up an appointment to meet with me, and I can help you through it. So, but that's the best way. Try to do it on your own. And if you get stuck, ask for help. So, all right. So with lambdas being said, right, our last thing, I want to have you do a breakout session, but I had trouble. I was going to have you maybe do like a lambda together, do an anonymous in our class, but I had trouble coming up with something that kind of tied everything together. So to talk about different aspects without making a huge project, because I know we don't have enough time for that, I tried to use different examples that I want you to find what's wrong with them instead. It's time for the breakout session. So what I mean by that is I have these sample programs, and what I'm going to do is I'm actually going to copy and paste them into the chat for you. So this is question 1. You can take a screenshot of it, or I can paste it into the chat. Okay, I will copy and paste it in there in just a second. And then this is question 2. And so what I mean by this is I want you to work as a group to see what's wrong with this. What could be wrong with that code? Now, you don't need to actually type this into NetBeans. You don't need to make it work. You can if you want to. But you just need to look at the code and see if you can use the examples in your book and what's in the book to see if you can come up with what's wrong. I just need a basic 1 or 2 line explanation of what's wrong with it. You don't need to actually fix it. Okay. Now, if you have extra time and want to fix it, that's great, but you don't have to. Okay, so those are the 4 questions. So what I'm going to do is I'm going to copy and paste those into the chat so you have them in there. And, or you could take the screenshots. Hold on. Stop.